Welcome to Daily Papers, the podcast where we break down fascinating new research papers into bite-sized pieces.
Today, we're diving into the world of AI agents, specifically agents that can take on complex technical tasks for you, like a super smart assistant for a software developer.
Exactly. Imagine telling your computer, hey, set up this entire web server and install all the software for my project, and it just does it. That's the dream of a terminal agent. The terminal is that classic black box with green text where developers type in commands.
But getting an AI to do that reliably is incredibly hard. This paper, called TermiGen, tackles two huge problems that are holding these AI agents back.
Okay, so what's problem number one?
The training ground. To teach an AI, you need to give it lots of examples and a safe environment. Think of it like training a student pilot. You can't just hand them the keys to a real jumbo jet on day one.
Right, you start them in a simulator.
Exactly. But for AI, finding good simulators is a major headache. On one hand, you can use environments based on real-world software projects, but those are often very specific, not very diverse, and take a ton of manual work to set up.
And the alternative?
You can have another, more powerful AI just imagine a computer environment and pretend to run the commands. The problem is these AI simulators often hallucinate. They make things up. The student AI might think a command worked perfectly, but in the real world, it would have failed spectacularly. It's like a flight simulator that doesn't properly model turbulence. It teaches bad habits.
So you either have a super limited, expensive training ground or a cheap, fake one that doesn't work right. What's the second big problem?
This one's really interesting. It's called exposure bias. Basically, we train these student AIs by showing them perfect solutions from an expert AI. The expert AI is so good, it almost never makes a mistake.
That sounds like a good thing. You want to learn from the best, right?
You'd think so, but picture this. You're learning to cook by only watching a Michelin star chef who never burns an onion, never misjudges a spice, never drops a pan. The first time you try to cook, you inevitably burn the onions. What do? You have no idea because you've never seen the expert handle a mistake.
You just panic and order a pizza.
Exactly. The student AIs are the same. They encounter a simple, common error that the expert would never make, and they completely freeze. They've never been taught how to diagnose a problem and recover.
Okay, so we have bad training grounds and students who only learned from perfect examples. How does this paper, TermiGen, solve this?
TermiGen is a two-phase solution. Phase 1 is all about building better flight simulators. They create an automated system using a team of AIs to generate a huge variety of realistic, verifiable tasks in environments.
A team of AIs?
Yep. One AI acts as a proposer, coming up with a task idea, like fix this bug in the database. Another AI acts as an evaluator, checking if the task is actually feasible and well-defined. Then, other specialist AIs write the necessary code, set up the files, and package the whole thing into what's called a Docker container, basically a self-contained virtual computer environment.
So they've automated the process of building high-quality, realistic training grounds. That solves the first problem. But what about the AI that can't handle mistakes?
That's phase 2, and this is the really clever part. They built a training system that intentionally teaches the AI how to fail.
They teach it to fail?
Well, more accurately, they teach it how to recover from failure. They use a setup called a generator critic. The generator is the AI agent trying to complete the task. But here's the twist. On every step, there's a 20% chance it's instructed to intentionally make a mistake.
So it's like a driving instructor who occasionally tells the student, okay, now I want you to try turning without using your turn signal, just to see what happens.
A perfect analogy. And then the critic AI steps in. It checks the mistake to make sure it's a realistic one, a common error a human might make, not just random gibberish. If the mistake is good, the command is run, and it fails.
And then what?
Then, on the next step, the generator AI is forced to look at the error message it just received, diagnose what went wrong, and figure out how to fix it. This creates training data that is rich in these little cycles of error, diagnosis, correction.
So it's not just learning the perfect route from A to B, it's learning how to read a map and get back on track after taking a wrong turn.
Precisely, and the results are pretty stunning. They fine-tuned a publicly available AI model using this TermiGen data. On a really tough industry benchmark, their model achieved a success rate of over 31%.
How good is that?
It blew away other models of a similar size. More impressively, it even outperformed some well-known proprietary models from major AI labs, models that are much bigger and have more resources behind them. This little model, trained on high-quality data full of mistakes, was punching way above its weight.
And they proved that the mistake-driven training actually works better than a model trained on the same tasks but without the injected errors.
They did. They compared it to a model trained on the same tasks but without the injected errors, and the TermiGen model was significantly better. But here's the most counterintuitive finding of all.
Go on.
They found that training the AI on data that included failed attempts, where the AI ultimately couldn't solve the entire complex problem, made it perform better.
Wait, learning from complete failures makes you better?
Yes, because even in a failed attempt, the AI might have gone through 5 or 6 of those little cycles of error, diagnosis, correction. It successfully learned to fix a bunch of small problems along the way, even if the final goal wasn't reached. Those little lessons in resilience are incredibly valuable. It turns out that filtering for only 100% perfect solutions is actually throwing away some of the best training data.
So the big takeaway is that if we want to build truly capable AI assistants, we can't just show them perfection. We have to create realistic environments where it's safe to fail, and then actively teach them how to pick themselves out after they do.
That's it exactly. It's not just about knowing the right answers, it's about knowing what to do when things go wrong.
A great lesson not just for AI, but for all of us. That's all the time we have for today. Thanks for tuning in to Daily Papers.